Hello, this is the FSAE electric vehicle team for Senior Design 1, and as you can see we have our poster which will be presented Friday the 10th at the Hilton across the street from the university. The objective of this project is to build an open wheel, open cockpit car that fits to the dimensions of a minimum 60-inch wheelbase, a maximum power output of 80 kilowatts, and a maximum voltage output of 600. And to do this, we have to verify our designs with calculations and simulations on several different softwares and provide supporting documentation for future teams. So for the next semester, we will be assembling the vehicle dynamics and powertrain systems and bench testing them on purpose-built rigs and to evaluate their performance and efficiency. The following team for the next year will be completing the full assembly and conducting a full testing program to prepare for the 2023 Michigan competition. Our total budget is $40,000, with most of that going to the powertrain due to the high cost of the batteries, motors, and other electronics. And at the bottom right is a flowchart of the whole motor control system. Some key parameters for the vehicle dynamics are that we created a double wishbone push-rod suspension with a wheelbase of 62 and a track width of 48 inches. We have a little bit of anti-squat and a bit more of anti-lift, which reduces the pitch forward and back under braking acceleration. The shocks we'll be utilizing are an Öhlins TTX 25 prior 2014 with 2.5 inches of travel. The tires we are using are a Hoosier R25B 16x6-10 on a 7-inch wide TJ forged wheel. Brakes are 2 front rotors and 1 single rotor, and the steering is a CAS Technology steering rack, which allows us 94 degrees left and right of freedom. The push rods will have a 1-to-1 motion ratio, and all uprights are from the IC car tube for ease of production and quick changes if something is damaged. And this has all been simulated using SimCenter AIMSIM and BTS 200. For the powertrain, we'll be utilizing an MRX 228 electric motor with a Drexel limited slip differential. The battery packs are 100 Energous 1 Series 6 parallel with Sony VTC6 batteries. The battery management system is a Orion 2. The maximum power output we'll be able to achieve is 97 horsepower at the conditions that we are using 360 volts and 180 amps. The maximum heat generated is 7.5 kilowatts. All of this has to be stored in an accumulator housing, which can be seen in the top right. And the capacity that we have of 6.5 kilowatt hours gives us a safety factor of 1.3 compared to past data from FSAE EV competitions.